So in 2013, I started to join a community. It was the NXT community, the first proof of stake blockchain that was launched by the founder also of Qubic, and it did solve many of my problems. So I started using this into corporate environments, trying to do proof of concepts. I was that at that time in Spain, and there was not a lot of movements in blockchain. It was like a dark era, when everything that happened with the Silk Road and so on. So I moved to London and I started to work there. Then, well, I've been working in the blockchain environment since then, as a business developer also since 2018, and now here we are. So I can say that I'm a passionate, I've been an entrepreneur myself, and I'm passionate about technology.
Welcome back to the Blockster podcast. We have the absolute pleasure to interview Alberto, who is the ecosystem and partnership lead at Qubic. Thank you so much for joining the podcast.
Thank you so much, Ivan. It's my pleasure to be here. It's a very big pleasure. I'm a fan of your work, so it's amazing.
Thank you so much. And before we jump into the technical details of Qubic and the issue that you're trying to solve, can you tell me a bit more about your journey into Web3 and your background?
Yeah, sure. So I was very lucky because I started almost from since the beginning of the blockchain era. I was a software developer, mainly working for integrating different companies each other, like building interfaces to communicate all of them as a middleware a software engineer. So when blockchain, Bitcoin kicked in, it solved one of the problems that I was having to solve the issue about having like us using the anti-pattern of integration using a common database. But what happened? Bitcoin wasn't enough. So in 2013, I started to join a community. It was the NXT community, the first proof of stake blockchain that was launched by the founder also of Qubic, and it did solve many of my problems. So I started using this into corporate environments, trying to do proof of concepts. I was that at that time in Spain, and there was not a lot of movements in blockchain. It was like a dark era, when everything that happened with the Silk Road and so on. So I moved to London and I started to work there. Then, well, I've been working in the blockchain environment since then, as a business developer also since 2018. Um, and now here we are. So I can say that I'm a passionate. I've been an entrepreneur myself, and I'm passionate about technology, decentralized tech, everything related to decentralized, the philosophy of Bitcoin and decentralization, plus also artificial intelligence.
Nice. And while I was preparing for the interview, my understanding is that Qubic is essentially a high performance L1 that does three very essential things. And one of them is instant finality, or like very close to instant. And it has feeless transactions, and it has really fast smart contracts. And even though we refer to it as a blockchain, you guys have considered yourself as a cube chain. Uh, so can you just start with the very hard, with the like instant finality and feeless transactions? How do you manage to achieve that? And can you tell me a bit more about the technology behind it?
The current bottleneck that we have in most of the blockchains, it relies on the database that it is responsible for persisting blockchain data. So, for instance, when you send a transaction and you broadcast the transaction, all the nodes in, let's say, Ethereum, they have to put this data into a database that will persist the data. So, Cubic eliminates the bottleneck entirely, but not using a traditional database. Instead, everything is stored in RAM memory, which is several orders of magnitude faster than traditional storage. So Qubic doesn't operate also on any existing operating system. So it has its own custom built operating system. So it allows to fully utilize the processor capabilities of the computers. So finality, it means that this is part of the new architecture. It's about the quorum. So we don't say that Qubic is a blockchain. We say that the Qubic is a tick chain where each transaction, when it happens, it's bought by all the validators, that we call them computers. So we don't have, when you send a transaction and it is stored, validated into a tick, it's not linked to the next tick. So it's isolated because it is considered that if the quorum approves this transaction, it's already persistent. So that's why we have instant finality. We don't have to wait until confirmations. If the transaction made it to the tick chain, then it's already done. And the last thing that you mentioned about the performance of Qubic, the main reason is that we have so great performance because we don't have the database. So the architecture is totally different. So the transactions are stored in memory when they are happening. And so we eliminate all the commits from the database, that the possible rollbacks that can happen, and that's our main advantage.
And can you tell me a bit more about the validators, or I'm not sure whether you refer to them as tech operators, but how do you incentivize them to join the current um, consensus mechanism, but also how do you incentivize them to provide accurate data and ensure that they only approve valid transactions?
Yeah, well, the validators, we call them computers. This is very high powerful machines that they need to qualify in order to be a validator. And how are you able to qualify? Um, we qualify based on the idea of useful proof of work. So it means that if you want to be a validator, then you must have a number of, or I would say like a certain amount of power, computing power, to be approved. So those validators, in order to be approved within the network, they must have miners that they are sending solutions. We don't call them now miners because they are trainers. They are training artificial intelligence. So for that, so the incentivization is based on a when each epoch the protocol has inflation, so they receive tokens based on their work. So they are also part of the quorum, and it means that they have to take care about the network, and they have to enforce the security and also validate the transactions that are valid. You know? So this is what we call the quorum. And the main thing that I want you to remark a little bit is that the Qubic architecture separates consensus, which is handled by these computers, from the computational power that is provided by these AI trainers or miners. So these facilitate a secure, scalable L1 for applications while simultaneously it harnesses the vast computing power for AI development. So it's a unique synergy that it was the idea of Come From Beyond, and it's working really, really good. So the incentivization, it comes from the protocol, it's weak, we have a chain of epoch, and the miners, the computers, they receive the income. So that's why. And why they are incentivized to only vote for transactions that they are valid. What does it mean? It means that each computer, when they use a transaction, they check that you are who claims to be uh, because of the private key, the signature of your transaction, and also they check that the behavior of the rest of the computers they are okay. But even if we have an issue about some computers that they are going rogue or something like that, we have a component that it's called the arbitrator that can act in case something is not done.
Thanks for clarifying that. And you mentioned that the miners within the consensus mechanisms are referred to as trainers. And my assumption is because you guys implement useful proof of stake consensus mechanism and essentially. Oh, yeah, sorry. No, no, thanks for the correction. Proof of work, consensus mechanism, and the remaining energy is not wasted, it's used to essentially train your artificial general intelligent model that we'll touch upon later on. But can you please tell me a bit more about this process of useful proof of work and how have you reached the consensus to implement it? And more importantly, like, why are you still using it? Because a lot of L1s transition from proof of work to proof of stake. So there are like two kind of questions there.
Why we are decoupling the consensus mechanism from the AI part. So when CSV, the founder, was thinking about how to create such a artificial intelligence totally decentralized, and we are aiming to have an artificial general intelligence, we need a lot of computational power, you know, as much as we can to do this research. So these trainers before last year, before the 4th of December last year, they were just creating artificial neural networks, just creating, and we were studying the results of the creation. So after the 4th of December, we changed this algorithm, and they are training already artificial intelligence. So they are feeding with data, trying to find solutions. And data, it can be, for instance, before we were using some compressed data that the artificial intelligence was trying to figure it out without applying anything else. So we have like a vectorization of validation, and when it reaches certain level, it was a solution. So they signed the solution, and they send the solution to the computer. So there is a threshold each week, and if you want to get approved as a computer, you must have, for instance, 500 or 1,000 solutions. When you have the threshold, and it's only a place for 676 validator, if you are among the best of them, then you are a computer for the next epoch. So it's a competition right now. The more power you have, the more secure you are going to be that you will be a computer, and the more secure you will receive your Qubic. And also, the more power we have, it's easier for us to continue with the research of the artificial for the research of the artificial intelligence. So this is a mechanism where the miners are enforced to do the job, and also the validators, they play a role. Most of the validators, they don't act by their own. What they do is that they have a commission, for being a validator, and they pay to their miners. So for instance, right now, if you want to be a validator of Qubic, I think you must have like around 300 right now, I think even more, CPUs that are running to finding these solutions. So this is the mechanism. I think it's such an unique mechanism that when I discovered, I really fall in love with the idea.
Okay, and Are you concerned about the fact that there might occur a concentration of power? And it's the same thing with Bitcoin and most of the proof of work blockchains, especially because larger companies will be able to become comparatively big validators, and there are multiple issues that could emerge because of it. And I don't think that we'll necessarily see 51% attack, but what we can see is if any of those big entities combine powers, they can start excluding certain transactions. And that would be a big problem because then they'll have control of who we can have on the blockchain. And the problem there is that it's so much harder to track because you can steal someone's money and it's easy to track. We're like, okay, my money is missing. But why if they just decide not to include certain transactions? And I guess you're not at this level yet, but is this something that you're thinking about? And I would love to hear your take on it.
Yeah, this is the theory of games that it works really well at the beginning. For instance, when Qubic started and there wasn't that much money right now, it was like a bunch of people, nerds, that they were playing with the computers, and they were doing each other the everything, like building the computers, buying hardware for that, doing the maintenance of the computer. That was the thing. But when once Cubic reached a certain amount of money and computational power, we see that it's naturally happen more companies and bigger entities to get into the network. So we can say that we have right now around, let's say, 10 big entities like this that they're competing each other and they want to have the more power as possible, but also they want to take care about the network. So they are the ones that they vote in the day in the DAO, the autonomous and the decentralized autonomous organization. So they have to take care about this because they have money in play. So we are seeing that we now have more entities that they want to get into play. For instance, very big mining companies. Very big mining companies, they have very good business with Bitcoin, but now they are moving into artificial intelligence. And that's something that I'm looking forward to it because instead of getting like issues where they can play something wrong for the network, or they can do something that it's not going to be good for the network. They are incentivizing the network to be stronger, to have more adoption, and it's a network effect. I saw it in the previous wave. When Cubic was like relatively small block L1, and now I see that it's coming to the next wave where we have requests from biggest entities to participate in that. And however, we think that, for instance, let's say that there is a country that want us to take over. Imagine that we have the point that we have reached the artificial general intelligence fully decentralized. So we are going to make many people to be annoyed, you know, because it's something that they are not able to control. So in that case, we have the option that the arbitrator can take the lead to compensate this fluctuation. So it's a theory of games that I was also worried at the beginning that something could happen about it, but now that I see that the more value we have in Qubit, the more adoption, the bigger companies we are having, the more serious professionals we are having into these computers, I think we are quite safe. It would be a problem if, for instance, now imagine that we have like a very big company and they want to gather like most of the computers, like more than two-thirds of the computer. So they could decide for the network. That would be an issue, but it's not possible to happen, because I saw this year, and this is the last part, that there were many companies trying to gather all the computing power, but when it happens, it naturally, all of them, they compete to also have everything. So it's something that I would say that we will see in the history books of economics, how it works, because it reminds me a lot how Bitcoin is started, you know?
Yeah, I absolutely agree with you. And my next question is again slightly technical because you claim to have 55 million transfers per second, which are executed on the smart contract. And my understanding is that transfers are essentially a change in the state of the ledger, and it's not a transaction per second because transactions are essentially part of a block. So could you explain that to me and also elaborate on the difference between transfers and transactions per second? But what's the I would also want to understand what's the difference between them for the company that's building on top of the L1. So let's say I'm building on top of Qubic and I'm building on top of Solana. One of like Solana has transactions per second, Qubic has transfer per second. Can you explain to me what's the difference there?
Yeah, sure, sure. So I can first explain with an example. And let's say that imagine that you have a tab that it works to do airdrops, where you can do one transaction, to let's say 1 million positions, 1 million addresses. So if you do this in Ethereum, it is translated into 1 million transactions that you have to pay the fees for each one. And in yeah, yeah, yeah. I discovered that, like 6 years ago, and yeah, it's a pain in the neck to have this. But in Qubic, what we have is that you can send a single transaction, you know, to do an airdrop, for instance, and you can have a decentralized application for that, and it can go to 1 million addresses. So it is one tick, let's say one single transaction that it goes to this amount of addresses, but in one smart contract. So it doesn't mean that you are using the same transaction to one to another. Okay, so that's different. If we say that, for instance, we are going to just send a transaction that directly generates one transfer, you know, under the current network parameters that we have, I think we are around maybe 1,000 transactions per second, what we can achieve, though it's artificially capped because we are decreasing the amount of, we are decreasing the tick time, and also we have capped this into the code because we don't need it yet. But when we are using smart contracts, then we reached the amount of 50 millions per second. However, you know that we did test in mainnet. This is one of the things that also people when they say where are the proof, it's because we did it in mainnet live, but we are also working with ChainSpect that they will provide all the analytics for a proper third party performance test when we do it. So we can say that if we talk about just transaction, that we go to the wallet and we make a transaction, we are capped in around in between 500 and 1,000 transactions per second. But when the smart contracts taking place, and there is, for instance, imagine a derivatives is the derivatives exchange where you have the order book. The order book, imagine that the order book is already in the RAM memory, and you can have like one many millions of trades, bits that happens at the same time. That's our main advantage. If we want to do this in with another blockchain, it doesn't work like this. There are smart contracts that it might involve a, a transaction for every bit, for everything that we want to do, and it doesn't work with that much capacity. So Maybe I can clarify a little bit more. If you have any questions,
No, while you're talking about it, I just don't feel like I have the technical understanding of the project to understand the downside of it. So I would love to hear your opinion of what's the disadvantage of having transfers per second and implementing this model, because I'm sure that there are some sacrifices that you had to make while you're building the L1. So I would love to learn a bit more about it, but I don't know how exactly to formulate the question because I don't have a deep enough technical understanding of the project.
yeah, there is one disadvantage that I can say that one disadvantage that we have is that we don't have mempool yet. So you know what happens in Ethereum, for instance, you have the mempool where you can have all the transaction and then it happen. So you have like a queue, you know. In our case, as we don't have mempool, you know, when you send a transaction, you have to wait until it's included into a tick to already confirm that it really happened. So it's a different way of working. It means that you have to track, you know, send a transaction and then wait for the including this transaction into a tick, and then you are okay, you know. And this is something that we have to deal with the exchanges. For instance, when we are integrated into an exchange, you know, they though we explain this very deeply in the documentation, sometimes they send a transaction, and because of the network, maybe some part of the network is not voting at this time, the tick quality is not that good, it's not introduced into the tick. So they think that something is failing, what the hell is happening, and so on. But once we explain what's the flow diagram that they have to follow for the deposits, for the sorry, this is not for the deposits, this is for the withdrawals, uh, then it's working very fine. And for instance, we have experience, very good experience with some exchanges that they have like the box of instant finality, and when they click on uh, doing a withdraw, it happens like 1 second, and you have it already in your wallet. You know, also you don't have to pay fees, so it works. So one of the the issues that I see with this architecture is that, but we are trying to solve it. You know, we are trying to build a mempool that maybe it can be implemented for this year, and it has an approach of having like a queue of transaction with a mechanism of retrying or checking what's happening. So it makes the life of some of the developers that are used to Ethereum easier.
That's really interesting, and I have a few more technical questions, but I'll refrain from asking them because I want to move to the AI part and talk about a guard, which essentially you described as the guardian of artificial general intelligence. And you mentioned earlier that you're training an artificial general intelligence. I was going to say bot, but it won't be a bot. It will be um, a model. So can you tell me a bit more about it and at what stage are you at? But also, based on your prediction and knowledge, how long do you think it will take us to complete that process?
I would say that we are maybe in the middle of the process to reach this artificial general intelligence. Um, Now we are in the process of also doing the research. For instance, we have two scientists in the team. One that is specialized in AI computing, longer than 20 years, and also we have another scientist that he's a neuroscientist, because we are uh, copying, we are taking how the evolution work in the nature, and we are replicating this into the computing systems. So the main creator of the artificial general intelligence that it's been evolving, it's come from beyond, and he also has the idea of replicating the structures that we have in the nature into computing power. So um, the first phase that I already mentioned, that we were doing this research about creating these artificial networks. Now we are training them, and we we had several very possible outcomes from the research last year. For instance, one of the most important research, the outcomes that we realized is that instead of having like only two possible outcomes, like true or false, we added another one. It's like uncertainty. I don't know, you know. And the fact that DeepSeek, when they launched and they broke, the entire OpenAI system. I would say instead of OpenAI, close AI system. So they were doing exactly the same. You know, in order to be more efficient, what they did is also to include a part of self training based on the I don't know state. So we were very happy about that because it shows that this is the way to go. Now, for instance, during this month, we are in the process of getting the number exact of neurons that we need for certain process because we don't know exactly. We are like tuning each week, and we are calculating how accurate was all the calculation, all the solution that we are doing. But we need like a dynamic mechanism in order to know what are the neural network that they has to be created for certain state. So we are quite close, to have like a possible agent where you can train and you can delegate the outsourced computation to train um, mm, whatever field that you need. But it will take, I think, to have something that really, really operational that you can use it for your daily life. It can be like 1 year and a half, 2 years, in order to have a fully operational. What we are doing is that we want the collaboration of more researchers, AI researchers. For instance, we are attending the ICLR conference in Singapore, where most of the relevant people from AI they are attending because we released a scientific paper back in December, and we want to have as many eyes as possible on it, not because we want people to copy what we are doing, but to spread the word that there is a different way than different to using tensors, traditional tensors, to achieve artificial general intelligence.
And earlier on, you mentioned that the underlying aim is to create fully decentralized artificial general intelligence. So, can you tell me more about the entire decentralization part, but also where will that be hosted and who will be the proprietor of it? And I know that you're building an open source, but then would anyone be able to emulate it and then create their own artificial general intelligence? Like the way we're spinning AI bots now, would that be would company be able to do that with artificial general intelligence as well?
Well, we are protecting a little bit that. So, for instance, the research that we are doing, it's not open source. So we are trying to gather the whole information, and once we are ready, we will people will realize that we are open sourcing everything. Mm, back in the day, we were quite okay, that we were quite protected because we gathered many computational power. We gathered an amount that when it was calculated, it was around like 1 million CPUs, like a massive amount of power. So it prevents, you know, another companies to try to replicate everything. But the piece of code that they are using to get feed into the miners to do the work and to achieve, let's say, the agents, the training, the AI agents, they are not released to the public yet, you know, because it would be possible that a very big company could take care of that. So we want to have like a proper um, material to do that, But however, everything is open source, but that so everybody can have a look, can see the code of the trainers, they can do their own research, they can try to do whatever they want. And in the future, the idea is that when we have the AGARTH in place, is that if you have a problem to solve and you have the data, for instance, imagine that you want to solve a physics problem that you are dealing with, you can make an auction, and say, I will put like this amount of cubic for the miners to train this data to solve this issue. And then the miners will accept the job, and this is like an outsourced computation, and they will do the job for you. So you you can have the data. It's not figured out yet who is going to be proprietary of what, or how are we going to feed the whole data. We know that we will use oracles, external oracles to feed data into the database. But when we are going to have that massive amount of data, uh, we don't have that. We haven't figured out yet what's the architecture that we are going to follow. But that's the main idea, how we want to move forward.
Yeah, that's super interesting. And while you're talking about it, I was just wondering whether you have or think about any ethical considerations, because I believe that we're entering the AI era and we're so unprepared for it, because even everything we're talking about now probably won't be applicable in 20 years. And I feel like that the same experience happened during the dot-com bubble, when at the beginning people envisioned the internet as something that would be utilized for certain purposes, but nowadays we use it for a completely different um, reason. And I'm just wondering whether you think that the same transition will happen with AI, and also like if we have artificial general intelligence and then Tesla is creating Optimus and then we just give it this physical body, then does it mean that it has consciousness? And then we get into this like very messy debate of like, oh, wait a minute, then like are they, should they have like equal rights as human? Which like obviously it sounds like science fiction, but if you're saying that artificial general intelligence is like 5 years away, then this reality is like 7, 10 years away, and it's scary. It's within our lifetime.
It is. It is. We do really care about that. If you have a look into the scientific paper, there is a section for ethics. That for us it's also really important. And if you go to the license that we have of the code, there is one special part, that you can use the code for whatever you want, but for military reasons. So this code can be used for any war at all. And the founder, took really, really care about, putting these clauses that it, it avoids this to happen. So if someone wants to use that, this is also scary, because now that you mentioned Optimus, and we think that it's like science fiction, but it will happen. It will eventually happen sooner than we think. And it makes me think that it's a very good moment to invest in hardware, because with this AI, we will need some hardware to put into. So yeah. And in the other hand, also, we will raise many concerns, ethicals, because the the state that we are going to have, because we don't know whether it's going to have a conscience, or not. Once, so, and there is a powerful AGI, but we took care of that. And how do we do it? We have a mechanism that if some of the part of the network they are trying to do misuse of the AI, the arbitrator or the quorum can act. And the quorum can act, it means that the whole network can vote to revoke access to someone that is doing harm to the network, or it's not complying with the license that we have or with the ethics that we all have. So that's the thing. We don't want. My vision, for instance, is that I don't like to have a centralized AI where you can put a lot of bias about, for instance, we have with DeepSeek, you're not able to talk about what's happening with Taiwan. If you do that, you are screwed because they're not going to say anything. So as less subjective as possible, where no one can trace control, but we everybody control. It's the same philosophy of Bitcoin.
And we mentioned DeepSeek a couple of times. So can you give me your take? How do you feel about it? Everyone was so excited the first week, but then we started realizing that they use GPUs that were made in the US. There's some bugs, there's some issues with the code. Actually, they spend a lot more money. They released only the first model and they have like a private one that they spend a lot of money working on. So it was like a very interesting transition from like excitement to realization. So the reality, like excitement to reality. So I would love to hear your take. Like, how did you feel about it?
Well, I saw several improvements about the training that they have. Also, I tested the model well locally with LM model, and also I tried Nebius to have the R1 model to see how good it is. And well, it's not perfect, if you compare to the new O3. Well, but it's very nice that we have like a different way of achieving similar outputs, The training, I'm not completely sure that it was that expensive. That if I recall correctly, it was like 10 millions or something like that it cost the training. But now they are saying that it was more, so we don't know. However, it's much less, than the training of the OpenAI models that we have before. But I really like the competition, you know, and it has started like the Manhattan Project wars between different countries. So it's amazing. Now the reaction from the United States from OpenAI it was like instant. They um, started to work on releasing new version, and I it forced to all the AI companies to release what the best that they have. So this competition, I think it's really good. And also, what I liked is that though they have a private version, these are one, that it's open source. It's really good, So it's helped us to know a little bit more about, new ways to achieve artificial intelligence. So for us, and also the journalists were very, eager to call us, to call me, to explain. Okay, guys, you were saying that this uncertainty it was okay. It was the way to go for this self training, you know. But in the other hand, we have more performance with CPUs, so we are quite different to them.
Nice. That's really interesting, and we can keep talking about AI. But I want to move to the projects that are building on top of Qubic and your tokenomics, so we can understand the project a little bit better. Let's start with projects. Earlier on, you mentioned that there are around 10 entities that are comparatively large and building on top of Qubic. You don't have to name them, but can you tell me the type of projects that are interested in Qubic, and just the unique selling point, I guess we've talked about it earlier on with like instant transaction, no fees. But yeah, if you can just, I guess, tell me the projects and why they're building on Qubit.
Yeah, there are several projects that they are public, so I'm very free to tell about it. And last year, during the last part of the year, we launched several programs, incubation program, and also grants program. And thanks to the incubation program, we started to have like nice projects. For instance, we have Nostromo. That Nostromo is the first launchpad in Qubic. It's with an alien theme. So cool. That it's similar. If you are familiar with ChainGPT, the launchpad, it's the same idea. We also have native bridging to Ethereum and Arbitrum. That this is a project that it helps to bring liquidity into Qubic, into the decentralization, to the DEX of Qubic. We have also integration with Layer Zero or other integrators that we're fine to do these seamless swaps, trustless swaps. We have also a game that it's called My Last Match. This is a game that is developed by CSV. He's one of the developers, so it's quite interesting because the thing that you don't have to pay fees for transactions for most of the transaction of Cubic. It really couples very well with gaming. The interaction is quite easy. We also have one, let's call it Uniswap in Cubic, that it will have liquidity pools. It will have the advantages of having these very quick transactions and the amount of transaction per second, the performance. We do have an official DEX, that it's used for all the shares of the smart contracts for all the tokens. That the part of the blockchain and the back office is already developed, but we are evolving into a new user interface that is going to provide a smooth user experience. And I want to mention that when we started with these programs, we realized that the onboarding of developers it wasn't that good because it's new technology and we are very familiar with it. But when we have someone that is from outside the community, it takes quite a bit. So that's why we are improving a lot of the documentation. We are also building connectors uh, for MetaMask Snap, for Wallet Connect, for Ledger. We already have a hardware integration with a hardware wallet that it's called Hash Wallet, um, and so on, you know. And we are building these pieces of code so more developers can develop on top of Cubic, having like a nice experience. Even, we realized that the developing smart contracts in C++, it's also that C++ is it's a very extensive programming language that many people know. But on the other hand, getting into the environment, it was like quite an effort for people, outsiders, for people from outside the community. So that's why we are very likely to build an online IDE where you can directly code. You will have snippets of code. You can have your libraries, and you can deploy directly into Cubic. I can say that we have also more projects related to more big companies related to mining that they want to collaborate, and big companies that they are mostly interested into the AI part. So we are having collaboration with them because they are looking forward when we have looking forward to having an artificial general intelligence to solve many of the issues that we have. So I would say that that's the main projects that we are having. We a little bit slow a little bit down because now it's not possible to onboard more projects, or it's possible to onboard more projects, but we want to make a perfect environment for the new projects to come. So once we have everything in place, we have, for instance, projects that they want to come. For instance, I mentioned earlier, derivatives exchange. They are shocked with the technology and they want to implement a derivatives exchange. We have also tokenization platforms for the same reason, because we can have a very high workload. And many projects that they want to have the portion into Qubic.
Yeah, that's really interesting. Sounds like there are a lot of projects building on top of Qubic. And earlier on, you mentioned that you are implementing bridging, like native bridging and bridging with the help of Layer Zero, and it's only to Ethereum and Arbitrum. Could you tell me a bit more about the rationale behind it? Why did you decide to choose only these two particular blockchains? Um,
Well, this was just the initial thought, to have like a couple of them, because we wanted to have an EVM compatible one, but we are also looking forward to having one in Solana. But then we have to prove that everything is working fine. In Ethereum, in Arbitrum, we want to have more liquidity and we want to bring also assets. We want to have a USDT or USDC. We want to have these wrapped tokens into Qubic because they can feed also the order book that we have with the decentralized exchange. But this is not just, we want to have just Ethereum and Arbitrum. Arbitrum, we want to have like the L1 Ethereum and also an L2. So from all of them, we decided to go with Arbitrum.
nice. Thanks for clarifying that. And to bring you back to the tokenomics, Qubic, the native token, could be used to pay miners to train your AI. That's one of the functions of it. And then because there's no fee for the transactions, I was just wondering what else can you use the token? But also, just to bring you back to the no fee, does it mean that you cover the fee? Because there definitely should be fee, or that's my understanding. But again, like I always think of like the conventional blockchains and how they operate.
Yeah, let's give you an example and you will understand how it works. The decentralized exchange of Qubic, it's a smart contract where you can create assets. If you want to create asset and one asset, you have to pay a fee, you know, just for the creation because you want to have your own asset, then you have to pay. Then for transfer this asset, that's okay. But if you want to do a trade, you will have to pay a fee. Okay. And where is this fee going to? This fee is going to the shareholders of the smart contract. And this is one of the things that it's totally different from any blockchain. When you want to deploy a smart contract into the Qubic network, uh, you have um, you have to do an auction, a Dutch auction. So there are like 676 places and you can bid, and if you are so lucky that you have one share of the smart contract, then you will have the exact amount of revenue from the execution of the smart contract. So it's an economic model. And also all the cubic that you are bidding, you know, if it achieves what you are looking for, then it is burned, you know. And that burned, imagine this, we have burned like more than 10% of the whole supply since the beginning. For the smart contracts that we are having, we have this. And also we have burns that are included into the protocol, into the tokenomics. So it depends on how many bars we're doing. We have like a component that we call it supply watcher that it adjusts the burning mechanism for each epoch. So we have the utility of the future AI smart contracts to pay the trainers We have the utility to buy shares for the smart contracts, and we have the utility also to pay some fees. Like for instance, if you want to create an asset, if you are trading, if you are using, for instance, I mentioned earlier, we have a launchpad, but if you want to do this, you want to do a launch of your project, you want to launch a token, you will have to pay a fee also for the launchpad, and it will be shared among all the shareholders.
Okay, thanks for clarifying that. That makes a lot more sense. Can you just tell me a bit more about your plans and what you're hoping to achieve in 2025?
Oh, well, there are like three different parts. One, we have the core tech that mainly I can say that they want to have more stability to the network. They want to decrease the tick time to be a little bit faster. They want also to improve what we mentioned about the mempool. They want to build the mempool. They want to create like an API for the smart contracts. So when you deploy a smart contract, it automatically creates all the interfaces that you need to call to the smart contract in a HTTP REST interface. They want to prove the mostly the onboarding. This is for the core tech and also the technology. Then we have the AGAS part, the AI part, that we are likely to have like a better roadmap this year. We want to keep on improving during this year the research that we are doing, and maybe to have an agent. But I'm not in that team, so I don't want to say anything, that it's going to make them angry a little bit. But this is the idea, to have maybe for this year an agent. Then we have the ecosystem, and the goal that we are aiming is to have at least 12 smart contracts already deployed. It means we will have 12 dApps already running on top of Qubic to do several purposes. We want also to improve the onboarding of, of the of the developers. It means more documentation, more tools, more libraries, and better guidance, a testnet already up and running, because right now to run a testnet, you have to create your own node, and it prevents many developers to do the testing. So this is the things that we are doing. Also, we are doing a hackathon, an international hackathon in March. We want also to achieve a listing of Qubic into an ETP. You know, we want also to be listed into a T1 exchanges, T1 exchange. We want to have more peer reviews of the scientific papers. This is more or less what we have in mind. And then for operations, and this is the last part, we want to have a proper legal entity. We want to have take care of the treasury, um, everything that is related to create like a sustainable foundation. It's going to be a legal entity that it doesn't prevent us to move forward with contracts, with hiring top talented people, and so on. So this is like the four main foundations that we have for this year.
That's so good. Thank you so much for the time and the conversation. It was so informative, and I've learned so much about Quebec and your ecosystem. So thank you so much for joining me and dedicating the time to have the chat with me.
Thanks to you. It was a great pleasure.
And just a final question, where can people find you and what's the best place for people to become active members within the Qubic ecosystem if or actually when they want to do it?
Well, I think now it's the time to join the community. It's one of the best moments because now we are growing a lot. The best way is to go to cubic.org and then go to the socials. We have like two main points of contact. Discord, the Discord server, official server, which is like impossible to follow with everything. It's a lot of happening there. And also Twitter. Follow us on Twitter, because we will provide all the most important information on Twitter, announcement, how you can participate, all the programs that we are running. So feel free to come, join, ask for me in the Discord channel, whatever you want. We are very happy to onboard more people.
And are you also on Twitter so people can follow you there?
They can follow me on my Twitter is Albefero, Albefero. You can find me there, you know, and also feel free to DM me, to tag me, to
Nice.
discuss everything about Qubic.
Pleasure. Thank you so much for joining the call.
Thank you so much.